Welcome to today's explainer. We're going to peek right behind the screens of the devices we use literally every single day and discover exactly how computers think. Now, I know it sounds like a totally complex topic, right? But by the end of this explainer, you're going to see that it's actually based on something you already understand perfectly well. We're talking about algorithms. And we're going to break the whole shebang down, step by step.
So let me ask you this. Have you ever helped someone bake cookies or, make a sandwich? Just think about that for a second. When you're in the kitchen prepping a meal, you don't just grab random ingredients and toss them into a bowl, do you? No way. You follow a recipe. A recipe tells you exactly what to do step by step. First, you get the ingredients. Second, you mix them together. Third, you pop them in the oven. It's a highly organized process.
Let's look at another really simple example of this structure. Imagine we're making lemonade. To get it right, you absolutely have to follow a specific sequence. Step 1, squeeze the lemons. Step 2, add the sugar and water. Step 3, stir. One step leads directly to the next. If you try to stir before you even squeeze the lemons, you definitely aren't getting lemonade. That sequential step-by-step nature of our recipe is incredibly important to remember as we move forward.
Okay, let's dive into this. At its core, an algorithm is simply a set of clear step-by-step instructions for a computer or a robot to solve a problem or finish a task. That is literally it. It's just a digital recipe. Now, computers are incredibly powerful machines, but here's the secret. They aren't actually naturally smart. They need algorithms to know exactly what they're supposed to do. So, just like you need a recipe to bake those cookies, a computer needs a recipe to function.
Section 1. Our morning algorithm, getting ready for school.
So, before we go entirely into the digital realm, you might not even realize that you actually follow your own algorithms every single day without even thinking about it. Watch this. 1. Wake up. 2. Get out of bed. 3. Brush teeth. 4. Get dressed. 5. Eat breakfast. 6. Go to school. Hear that rhythm? It's a pattern. It's a sequence. You naturally order your actions to complete the larger task of getting ready for the day. If you mix up the steps, like trying to get dressed while you're still fast asleep in bed, it just doesn't work. Human routines are essentially our very own algorithms.
Section 2. Computers following algorithms. Play a game.
All right, let's pivot from the physical world over to the digital world. Think about your absolute favorite video games. Every single thing that happens in those games runs entirely on step-by-step instructions, and this brilliantly illustrates the connection between the two worlds. On one hand, you have a human command, like stir the batter. It's clear, it's direct, but on the other hand, you have a computer algorithm for a game character. Lift up, then come down. When you're playing a game and you smash that button to make your character jump, the character doesn't just magically know how to jump. The game's algorithm gives the character a very precise command. Lift up, then come down.
And it applies to even more complex actions too. When a game character searches a map to find a glowing treasure chest, it's just following a precise algorithm. The character moves along a predetermined path on the map because the code, the digital recipe, gave it sequential instructions on exactly where to search. So all those amazing things you see happening on screen, they're just strings of these simple digital recipes.
Section 3. Real-life story. The robots dance.
To really lock this concept in, let's look at a quick story from our source material. This is about a young girl named Lily who decided she wanted to program a tiny robot to do a dance. Here is her algorithm. Move right arm up. Move left leg out. Turn around. Clap. Think about that for a second. She couldn't just casually speak to the robot and say, hey, do a cool dance for me. The machine wouldn't understand. She had to break the entire dance down into distinct, separate actions. She had to give the robot a clear, sequential recipe.
And guess what? The robot followed each step exactly, and voila, it danced. But here is the absolutely crucial takeaway. It couldn't make up new moves on its own. Machines only do exactly what they're told. If Lily decides later on that she wants a totally different dance, she can't just ask the robot to improvise. She actually has to change the algorithm and write a brand new digital recipe.
Section 4. Algorithms are everywhere. Building blocks of AI.
So the crucial point is that these simple steps we've been talking about, these digital recipes, are the absolute foundation for literally all the technology in our world. Every app, every program, every digital tool relies on these structured sequences. Which leaves us with a pretty provocative thought. If simple algorithms make a robot dance, how will artificial intelligence use them to sort, find things, and help us next?
We've seen how just a few lines of instruction can make a game character jump or a robot clap, but artificial intelligence, it uses thousands and millions of these algorithms to solve massive problems. Just imagine what those complex digital recipes will be able to do in the future. Keep that exciting thought in mind the next time you pick up a device. Thank you so much for exploring algorithms with me today, and I really hope this changes how you look at the technology all around you.